Okay, folks. So let's go ahead and go on. So we have here a sodium hydride, right? And then we have a CH3I that we're following this up with. Okay? And so is sodium hydride a better base or is it a better nucleophile? Better base, right? And so if we take our current reactions we're talking about and basically slot them where SN2 used to be, right? What sort of reaction are we looking at for this? Are we looking at attack here or here? Yeah. The alpha carbon, right? The one next over. Okay. So it's going to be this next one over. And that's because you're pulling the electron density through here. That makes these alpha hydrogens very acidic, right? And that was that same logic that we had back in E2. Remember we did the SN1, SN2, E1, E2 back last semester. And we had to figure out which one was more likely to happen. So it's going to attack in an E2 style mechanism, right? So we're going to get hydrogen gas escaping. This is one of the reasons why this is such an effective base, by the way, is because it makes it gas, which then leaves the system, right? And so no back reaction because your hydrogen's gone. So what's going to end up happening then is you're going to have generated a pretty dang good nucleophile right here, right? This is then going to attack the carbon right here in an SN2 style mechanism with iodide being your leaving group. And so the iodide will leave. This will then leave you with the CH3 added at that alpha position. And that's going to be a racemic mixture. Okay. So again, a reminder that the reason the alpha positions are so stabilized is they can be pulling into bonds here, which stabilize them, right? Okay. So you get stabilization of the alpha position, or another way of thinking of it, your orbitals align correctly to pull electron density away from it. Partially conjugation in this case, but when you don't have a double bond, it's because of the orbitals aligning. You pull a little bit of the electron density over onto this carbon here.
Can you explain why you can't do the photon transfer?
So this one right here, if we were to attack that, that would leave a lone pair that would have to be partially next to that pi bond. And so that actually destabilizes that structure. Okay. And so this is actually the less acidic, more destabilized one. Right there. And it has, if you go back in the older chapters, there was that part where we had the orbitals matching up. It has to do with those orbitals matching up. So, but the general rule being, the easy way to think of this is actually just slotted in with, remember those last rules we did last semester? And we were like, what conditions does an E2 happen versus E1, SN2 versus SN1? That's the easiest way to deal with this, is just slot it directly into those rules. SN2, right? Yeah. We've just added another type of SN2, essentially. Does everybody understand why this is racemic, by the way? Okay. Can attack either side, right? Okay. Very good. You all have a wonderful day. I will see you on the flip side. What do we have coming up? Exam, yeah. So please make sure you prep for that exam early and get nicely prepped.